Greetings again. I'm Froneman, and for my second presentation, I will be giving you a brief overview of another focus of my research project. The title of my second presentation is Evaluating RIMpro, an ascospore release forecasting model, and fusi orchard monitoring methods for improving apple scab management. Disease prediction models form part of a strategy used to predict disease severity for an oncoming season to try and determine the most effective management strategy. Models commonly used in South Africa include RIMpro, which predicts severity of scab infection events by using ascospore maturation release simulations together with weather data. Another model is iLeaf. The predictions use only weather-based data. So the prediction models are useful for predicting severe infection events that will require follow-up curative fungicide applications after the infection event. Severity of scab infections are also determined by the amount of ascospores that will be present in the spring. These predictions are known as potential ascospore dosage that can be assessed in orchards in autumn. Therefore, the aims of the project was first to assess potential ascospore dose grower-based models and to also evaluate the accuracy of RIMpro predictions. Three objectives were needed to reach the aim. The first being the evaluation of three PAD grower-based models, varying in their time required to conduct them. Secondly, using potted trees to evaluate RIMpro's predicted infections. And lastly, using ascospore spore samplers to evaluate RIMpro's predicted ascospore releases. So for the first objective, three PAD models were evaluated and all were found to be effective. The first model was the number of fusi lesions. In this model, the number of fusi on 10 shoots per tree was counted and repeated for 60 trees in an orchard. The second was the percentage fusi shoots per 25 trees. This method was again the number of fusi shoots were counted on only 4 shoots per tree and repeated to 25 trees per orchard. And then the last method was the percentage of fusi shoots per 60 trees. Again, the fusi shoots were counted on 4 shoots per tree and repeated for 60 trees an orchard. A good correlation was observed between the labor-intensive evaluation method and the two less labor-intensive counting methods. Then for the second and third objectives, RIMpro was evaluating using spore samplers and potted trees. Spore samplers were used to determine the quantity of ascospores present after each infection event, and the potted trees were placed in the orchard work rows and were used to determine the number of lesions on trees resulting from each infection event. The potted tree results were summarized as the general observations from 5 orchards over 3 seasons and were grouped into 2 scenarios. So the graph showed the actual percentage fusi infection versus the RIMpro predicted fusi infection. The colored blocks were used to show some of the differences. So in scenario 1, RIMpro overpredicted 2 severe events, but more importantly, missed the actual events according to the lesions found on the potted trees. In scenario 2, RIMpro accurately predicted 3 major events, which correlated with the results from the potted trees. So the spore sampler results were again summarized as the general observations from 5 orchards over 3 seasons, but summarized into 3 scenarios to show the variance. So the same was seen as with the potted tree results. RIMpro sometimes overpredicted or missed severe events. Conclusions that can be taken away from this project thus far is that the risk of apple scab occurring in the spring in an orchard can be determined in the previous autumn by using a less labor-intensive PAD assessment method. This method is the percentage fusi shoot on 25 trees method. This will enable the identification of high-risk orchards and allowing them to be sprayed first. Second conclusion is that RIMpro did not always predict the severity of infections correctly. This is likely due to incorrect ascospore maturation predictions. And then future work that will be done is that experiments will be repeated for another season to confirm the results obtained. The members of the project team include myself, Al Zain, Durey de Villiers, Professor Adele McLeod, Philip Rebel, Trevor Koopman, and Becker Wessels.